Okay, we're working into section 3.6. We're going to do the first two examples in the first video and finish off on the second video. First of all, we have more theorems. These theorems are on the document I uploaded to Weebly that just contains all the postulates, theorems, and definitions we've done so far this year. So they're already there. Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if I apologize, I have my squeaky pen today. I can't find my other one. If I have two angles, that's going to drive me crazy. If two lines intersect to form a linear pair, so angle 1 and angle 2 are a linear pair, then angle 1 is also congruent to angle 2. Then we know that line G is perpendicular to line H. Okay, that is our Theorem 3.8. Theorem 3.9, if two lines are perpendicular, then they intersect to form, so these are perpendicular, we'll do B and A, then they intersect to form four right angles. So we know if A is perpendicular to B, then angle 1, angle 2, angle 3, and angle 4 are right. Alright, let's try one. In the diagram, AB is perpendicular to BC. What can you conclude about angle 1 and angle 2? Well, that's pretty simple. If AB and BC are perpendicular, Theorem 3.9 says they form four right angles. So we say that angle 1 and angle 2 are right angles. Can't spell. No. Sorry. Technical difficulties. Can't erase anymore. Are right angles, and angle 1 is therefore congruent to angle 2. Another theorem. If two sides of two adjacent acute angles are perpendicular, so two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Let's draw that. Hopefully it'll make better sense. Okay, I have adjacent angles here. So if two sides of them, I have side 1 and side 2, if they are perpendicular, then the adjacent angles, let's say angle 1 and angle 2, are complementary. So BA, BA, ray BA is perpendicular to ray BC, then angle 1 and angle 2 are complementary. Let's try this one. Prove that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Here's a little reminder. We're proving a theorem. I cannot use the theorem to prove the theorem. I have to use other postulates and theorems we've learned prior to 3.10 to prove 3.10. It's a very important point. So let's look at this drawing and write down what we know. So we have the given. Okay, ED is perpendicular. That's ray ED is perpendicular to ray EF. And that is given. Whoops, sorry, turned off my pen. There we go, and that is given. Okay, what else do we know? Well, it says right there that angle DEF is a right angle. Intersecting lines intersecting lines. That is, reason 2 is perpendicular lines form 4 right angles. Okay, theorem. This might be one that I actually write the theorem because that's a lot of writing. Theorem 3.9. Okay, we also know that the measure of angle DEF is 90 degrees. We know that because of the definition of right angles. What else do we know? We know that the measure of angle 7 plus the measure of angle 8 equals the measure of angle DEF. We haven't used this one in a while, but that is our angle addition postulate. Can't forget that one. And we also know the measure of angle 7 plus the measure of angle 8 equals 90 degrees. That would be substitution. Therefore, angle 7 and angle 8 are complementary. Definition of complementary, complementary angles. Lots of steps, but not necessarily difficult. Right, you try. Given that angle ABC is congruent to angle ABD, what can you conclude about angles 3 and 4? Explain how you know. Okay. Oh, push pause, please. So we know that those angles are complementary. Theorem 3.8 says if two lines intersect to form a linear pair of congruent angles, and this says that they are congruent, then the lines are perpendicular. And then Theorem 3.10 says if two sides of two adjacent angles are perpendicular, then the angles are complementary. Okay, this side and this side are perpendicular, so those are complementary. So that's it for part 1. We'll continue in part 2.